Welcome to the tutorial FLAC3D Cluster Computing with Rescale. This is Jim Hazard, ITASCA Software Manager. So as of version 9.2 of FLAC3D, you have the ability to run FLAC3D on a cluster. What this means is that you can divide up your model onto multiple computers that are connected by some sort of fast internet connection. And this will allow you to divide up a very large model into smaller pieces and have them running in parallel and get your solution much more quickly. Now, most people do not have such a cluster lying around the office. It is also quite challenging to spin up one of these clusters on the standard cloud computing services like AWS or Google or Azure. Because of this, ITASCA has entered into a partnership with a company called Rescale, which makes it very easy to spin up these clusters and run FLAC3D on one of the clusters. So in order to do that, first you need a FLAC3D version 9.2 with a cluster option. Assuming you have that, you just go to a browser and go to rescale.com. If you have never been here before, you will need to set up an account. I have already been here, so I have an account, so I just need to go to login. It will ask you for your name, your username, which is usually your email and your password. Since I've already done this before, it just remembered me and brought me straight to this screen. So once you log in, this is the screen that you see. What you can see across the top here are different things that you can do, and the most important ones are jobs and workstations. So workstations are if you want to run FLAC3D in the traditional way with the GUI on a single computer and look at it as you're doing the calculations. We have a separate tutorial about how to do that. It is also very easy to run on the cloud FLAC3D using a workstation system like this. And this allows you to run the GUI version of FLAC3D. The cluster version of FLAC3D, at least on Rescale, uses the console version. And so when we want to run the console version of FLAC3D and we want to run it on a cluster, we don't choose workstations, we choose jobs. So you choose jobs. I haven't got any jobs active at the moment, so I need to create a new job. So I just go to New Job. Create new job. You can see here it's possible to save templates. So if you set up a job with the given computer type and data files and so on, you can save it as a template. We don't need to worry about that right now. So I create a new job. The first thing to do is give it a title. So let's call it testing. And then you have a very nice workflow here where you just walk through from left to right, and it tells you what to do, and it's actually quite easy. So first thing we need is inputs. Because we're running the console version, what we want to do is upload a data file or multiple data files, and it will automatically start up the console version and run them. So if you have multiple data files, you'll want to have some sort of driver file that calls all the sub data files and so on. In this case, we'll just do a simple test. This is what the simple test looks like. I have it open here in FLAC3D. It's just a simple model, 200 by 200 by 200 zones. This works out to be 8 million zones. So it's a reasonably good test for the cluster version. It gives it more Coulomb material, assigns some boundary conditions, turns on gravity, and then just cycles 100. We have a little timer here so we can see how long it takes to run these 100 cycles. This is useful because you want to compare maybe how long it takes to run on 4 nodes or 8 nodes or 1 node or so on. And then at the end, you probably want to have a save state. Now, the important thing about these data files is if you're running on a cluster, you need to give this command on line 6, model configure cluster. This tells it you're running it on a cluster and to divide up your model onto all the available nodes so that you can get this fast processing power. You don't need to say anything about how many nodes there are, or you don't need to divide up your model by hand or anything like that. It's intelligent enough to just divide up the model in the most appropriate way on all the nodes that are available, and then bring that information back together again at the end when it makes a save file. And when you have a save file at the end, you can just restore that in a regular instance of FLAC3D and look at it. Because we're running the console version, it's also a good idea to take a log file. So with these two commands on lines 3 and 4, you can set up a log file and turn it on, and everything that's written to the console will also be written to this file. So that will be useful to look at afterwards. You can also add this line 2 program echo on just to make sure that all the commands are echoed in the console. That should be on by default, but there's no harm in adding it here. So this is what a data file might look like. So if I go back to my Rescale, it's asking me for inputs. You may have some inputs already on the cloud in Rescale. In this case, we don't have anything here, so we're going to upload from the computer. So I just need to find the file that I was talking about, and I'm already in the right directory here, so I just choose simpletest.dat, and it uploads it. There it goes. Okay, so I'm done with the input. Again, you could have multiple inputs. You could even upload a save file and start from that. In this case, we'll do all of the building and running and saving with this data file. So I go to next. Now I need to choose what software I want to use. This is a list of all the software that's available on Rescale. Somewhere in this list is FLAC3D. You can scroll down and look for it, but it's easier just to start typing in the search bar. So if I type FLAC, there it is there. And notice that this is actually a ITASCA suite. So it includes all of the software, but only FLAC3D is available in a cluster version. If you were running the workstation, you could run one of the other software programs and, for example, run a 3-deck model. If we're doing cluster, we only have FLAC3D. So I choose this. It will automatically load up the latest version of FLAC3D. While I'm doing this recording, the latest version is 9.1. Here is the test file that I just uploaded. Here is the command that will be issued, FLAC3D-MPI, and then some file name. And so almost always what you want to do is click this button, autofill input file into the command. So now the command is FLAC3D-MPI simple_test.dat. This FLAC3D-MPI command is actually a small script that simplifies a more complicated command. It figures out how many nodes you have and distills down the actual command into something simpler. The actual command would look something like this. I have it open in FLAC3D. If, for example, you had your own cluster and you were running FLAC3D, the command you would give would be something like this: MPI exec -n4, where 4 is the number of nodes, FLAC3D console, which is just the name of the executable, and then the name of the data file in quotes. We don't have to worry about that complexity. Rescale takes care of it for you. You just tell it which data file you want, and you're good to go. The last thing we need to do here is to tell it about what license we have. Because again, this is the console version. You can't go in there and open the license dialog and type in your email and your password. You need to send it your license information, and it will do that for you, but you need to fill it in here on the screen. So I can say use existing license. I put in my email. So here's my email. And then I put in my password that I use for my web license. And here I'm just going to say use saved value. Now I go next. The next step is choosing the hardware that you want to use. So there's all these different, what they call core types. These could be computers that exist on AWS or Azure or Google. You don't actually know. It doesn't necessarily tell you where they're coming from, but it doesn't really matter. You just pick the computer type that you like, and you can use that to run FLAC3D. It tells you all the specifications of these different computers, including the price. This is the price per minute. So let's say, for example, we're going to choose Emerald Max. It gives you two prices here, on-demand economy and on-demand priority. If I hover over the I for the economy, it's basically telling me that you may or may not have to wait in line for these resources because people who've chosen the priority will get the first priority. So depending on how urgent your job is, you may or may not want to choose priority. I usually do because I find that choosing the economy, you sometimes end up waiting around for your job to get started for computer resources to free up. So let's choose on-demand priority. That is 7.3 cents per minute, and it works out to roughly $4 an hour for this type of computer. That is per node, okay? So because we're running on a cluster, what we actually want to do is run more than one node. And the way to do that is to increase the number of cores up here. So by default, it says you've got one node with one core. That's not particularly useful. So you can bump up the number of cores here. This particular type of computer actually has 36 cores. So if I increase the number of cores beyond 36, it actually tells me I'm now using 2 nodes. So what this means is that I've got 2 separate computers linked together. And so the total number of cores is actually 72. So just for fun, let's make it 4 nodes. So now I've got a total of 144 cores. But note that I'm using 4 nodes, so the total price will be 7.3 cents per minute times 4. Okay. All right, so this is the computer. I'm happy with that. Note here I can also set the wall time, which is just a fail-safe, so that if for some reason you forget to stop the job or something bad happens, it will automatically terminate the job after some amount of time, so you don't continually getting charged this amount of money every hour. So it's a good idea to set a wall time here. The default is 48 hours. So I'm happy with all of this. I can scroll down to next. You could, in theory, specify a post-processing script. We don't need to do that, so I hit next again. Here's all the information. Everything looks good. And now all I have to do is hit submit. So this automatically fires up the 4 nodes. It automatically loads up the most recent version of FLAC3D onto all the nodes, and it will automatically call the FLAC3D console version on the head node, spray out the model to the 4 different nodes when it's doing the computation. And if everything happens successfully, it will automatically stop the job as well. If it doesn't happen successfully, you may need to stop it by hand, but that's super easy, and I'll show that in a few minutes. Now, spinning up these clusters and loading up FLAC3D and all of this business takes somewhere between 10 and 12 minutes. So you can see here it's telling you that it's starting the cluster. This is going to take probably around 10 minutes. So I'm now going to stop the movie and rejoin again when it's ready to go. You can see that the cluster has started. It took 10 minutes and 58 seconds. The job is now running. It's been running for 1 minute and 26 seconds. What we would like to do now is see what's actually happening. Down here is a window. Right now we can't see anything in it. And then theoretically there's a list of files, which we also can't see anything. So what you want to do is hit refresh here. And now you can see files that are being created. So here's the mylog.txt file that we set up. Here's the simple test dat file that we uploaded. And this is an important one here, process output.log. This is actually a live log that's showing you what the console is doing. So if I click on this one, I can actually view it, what it's doing on the FLAC3D console. So here are the commands assigning friction, zone face skin, skin assignments, and so on. So it's just walking through the data file. Now, the FLAC3D cluster version, the way it works is that it builds the entire model on the head node. So the head node has to have enough memory and power to be able to hold the entire model in memory. You can build the model on the cloud, as I'm doing here, or you could build the model on your own computer, upload the save file, and just start calculating. The cluster part of the calculation only occurs during the calculation, during the cycling. So everything it's doing now, assigning properties and adding faces and so on, it's doing on a single node. And then as soon as it starts doing the cycling, it will divide up the model into different pieces, in this case, 4 different pieces. Each of those nodes will run its own calculation. There will be communication back and forth. And in the end, we should get something that is probably not 4 times faster than running it on a single node, but maybe close to 4 times faster than running it on a single node. So this is going to take a few more, maybe a minute or two to get to the part where it starts cycling. So I'll drop off the recording again and join again when it starts cycling so you can see what it's doing. Okay, we're near the end of the setup here. So it finished. It assigned gravity, starting the timer. All right, now is the fun part. So look, it says model cycle 100, cluster gathering, partitioning information from model, partitioning model into 4 regions. So this takes a little bit of time. It's dividing up the 8 million zones into 4 different pieces, configuring the model. And here we go. Process 0 has 24,589 ghost grid points. Process 1, process 2, process 3. So what actually happens is that the grid points at the boundary between the different sections of the model are actually duplicated. So you have these ghost grid points. So this tells you something about the amount of communication required between the different pieces. Sending the model to the follower processes. So now it's basically just sending out those different pieces to the different nodes. And any second now it's going to start cycling. Remember that for this model, we only had it run 100 cycles, so it doesn't take very long. I think it takes about a minute. Oh, and also the head node becomes one of the calculating nodes. So it no longer needs to hold the entire model. It needs to hold 1/4 of the model. So that's what this says, shrink on the head node, on the leader node. Now it's doing 100 cycles. This is going to finish in a second, probably. And if we've done everything correctly, it will automatically shut itself down. It automatically appends a quit command to the end of the data file. Here we go, cycle of 100 met, gathering model from the follower. So now what happens is, because the model is in 4 pieces, it needs to bring all those 4 pieces back together to the head node so that it can make a save file. And then you have the whole model again in one location, in one save file, and you can look at it either with a workstation on Rescale, or you can download it and look at it on your own computer or whatever you want to do. So again, it's only the calculation part that gets spread out over the 4 nodes. And once it's done gathering everything back together, we had a save at the end, if you recall. And assuming everything works, it then should automatically stop itself. Okay, there it goes. Printing out the time, and then it's saving it, and that will take a few seconds. And then assuming everything works, it's just going to stop itself. The save file should appear over here in the list of files. And let's just wait and see if it works. Okay, here we go. So it saved the file to test.save. It automatically gives a quit command, and this should now shut down. Test.save should appear over here under run files. And again, it might take a few seconds just to get everything shutting down. Exited with code 0. That should be fine. Oh, now it's saving the files to the common directory that Rescale uses, so that when this computer itself shuts down, the save files don't disappear. They'll have access to them after this computer shuts down, or after this cluster shuts down. Okay, it looks like we're done now. Everything worked as expected, and it's automatically shutting itself down. So here's shutting down cluster. Again, this will take a few minutes, so we don't need to sit here and watch it, but we can assume that everything here is working. While we're waiting, we can go and look at the files. So it automatically created a bunch of files and saves them in a common place. So again, when that computer shuts down, you have the ability to go and look at them. Here's the data file that we originally uploaded. Here's the save file that was created. You can see why it took so long, because it's 16 gigabytes. And if we scroll down here, we should also be able to see the log file. So here's the one that we created, mylog.txt. Just clicking on it automatically downloads it, and we can open it and have a look at it. And so here's the log file of everything that happened during that run. And you can make sure that everything is correct. And then again, of course, you could download the save file and look at it, or you could open a workstation and look at the save file on Rescale if you don't want to download it and you just want to leave it sitting there on the cloud. So that's basically the end of this tutorial. This job is finished. You can see it's got a green check mark. Everything's done, and the job is shut down. We do not have to do anything. So that is the end. Thank you for joining.